In this illustration, an equiconvex lens is cut symmetrically perpendicular to the principal axis. This equiconvex lens, it is cut symmetrically and it got two sections, two parts, first part and second part. Two parts are silvered as shown in the figure. This is the first case and this is the second case. In the first case, this flat surface is polished. In second surface, curved surface is polished. We need to find the focal length of the equivalent mirror form. We need to calculate the focal length in case 1 and case 2, right? Let us first consider case 1. This is the case 1. Before calculating the equivalent focal length of the mirror, we need to find the focal length of this part. For calculating the focal length, we use lens maker formula, that is equal to 1 upon f equal to mu minus 1 upon r1 minus 1 upon r2. Here this is r1 and center of curvature will be on the right hand side. That means r1 will be with the positive sign and center of radius of curvature is 20 centimeter. So r1 should be equal to plus 20 and this is flat surface infinite. R2 should be infinite and this is equal to 3 by 2. Now we can calculate this is equal to 1 by 2 multiplication 1 by 20, right? That means focal length of this lens form is equal to 40 centimeter. But for calculating power, we need to calculate focal length in meter. So for calculating this value in meter, divide by 100. This is equal to 40 divided by 100 or 2 divided by 5 meter. This is the focal length in meter. Now we know the power of the lens equal to 1 upon focal length with a positive sign. So we can write power of the lens equal to 1 upon FL. So here we can write 1 divided by 2 divided by 5 or 5 by 2, 2.5 diopter. Okay. And power of this flat mirror is 0 because focal length is infinite here. So here we can write focal length of mirror equal to infinite and power equal to minus 1 upon focal length. 1 upon infinite will give the 0 value. So this surface is having 0 contribution for the power. Now let us write the power of the lens and power of mirror. 2.5, right? And this is 0. Now we can observe if ray incident on the system, it will interact the lens first, second time it will interact with the mirror and third time it will again interact with the lens. So here we can write power of the equivalent mirror equal to 2PL plus PM, right? PL equal to 2.5, PM equal to 0. So this is equal to 2 multiplied by 2.5 plus 0, that is equal to 5 diopter, right? Now we know this system is going to act as a mirror and focal length of the mirror should be equal to minus 1 upon equivalent power because power equal to minus 1 upon focal length. So here we can write focal length of this equivalent mirror equal to minus 1 upon equivalent power and this value is 5 diopter. So it is minus 1 upon 5 meter focal length and in centimeter if we multiply by 100 this is minus 20 centimeter. This focal length is with the negative sign, that means we are getting the concave mirror of focal length 20 centimeter. Okay. Now consider the case second. This is the case second. Here we have polished right surface, that is the curved surface. Let us calculate the focal length of this lens again using the lens maker formula. This one mu equal to 3 by 2. R1 is infinite because it is a flat surface. R2 equal to 20 and center of curvature will be on the left hand side. That means it should be substituted with the negative sign. This will be minus 20. So let us substitute the value. After calculation, this is equal to 1 by 2 multiplication 1 by 20. That is 1 by 40. That means focal length of the lens equal to 40 centimeter. In meter, if we divide by 100, that is equal to 2 by 5 meter with a positive sign. Now let us calculate the power. Power of the lens equal to 1 upon focal length with the positive sign and focal length equal to 2 by 5 meter. So this power is 2.5 diopter as we calculated in the previous case. Now focal length of the mirror equal to radius of curvature divided by 2, that is R2 divided by 2, secant surface radius of curvature. And as we know, the center of curvature will be on the left hand side, that R2 should be with the negative sign. So here we can write minus 20 divided by 2, that is equal to minus 10 centimeter, and in meter it is minus 1 by 10 meter. Now we know the formula for the power of the mirror, that is Pm equal to minus 1 upon focal length, and focal length equal to 1 by 10 meter with negative sign. So we can calculate from this formula, that is power, that will be with the positive sign, that will be in 10 diopter. Okay, this is a 10 diopter. Now we can write this power and this power to the next page. This is the power of the lens, 2.5. This is the power of the mirror, that is 10 diopter. Okay. Now we can observe here again the ray interacts twice with the lens and once with the mirror. So here we can write power of the equivalent mirror equal to 2PL plus PM. Okay. Now PL equal to 2.5, PM equal to 10. Now this is a 15 diopter. So here we got the power of the combined system, which is forming a mirror. And we know mirror, the focal length of the mirror is equal to minus 1 upon power, because we define power of the mirror equal to minus 1 divided by focal length. That means focal length of this system can be written as minus 1 upon equivalent power, and this value is 15 diopter. So it is equal to minus 1 upon 15. That means focal length of the equivalent system should be equal to minus 1 divided by 15 meter. We can change this value into centimeter by multiplying this value by 100. So it is 100 divided by 15 centimeter, and after simplification this is equal to 20 divided by 3 centimeter with negative sign. Negative sign here represent the system is acting as a concave mirror of focal length 20 divided by 3 centimeter. Right. Now let us move to next illustration. In this illustration we are given this figure. We can observe the surface, rightmost surface is silvered. We have two lenses. Refractive index of this lens, first lens is 1.6. Refractive index of this lens is 1.2. This radius of curvature is 80 centimeter. This radius of curvature is 40 centimeter, and third surface radius of curvature 20 centimeter. Here the object is placed at a distance 12 centimeter from this system, and here we need to find the final image position. Okay. We know this system will act as a mirror. So here we need to calculate the equivalent focal length. For calculating equivalent focal length, we need to calculate the focal length of this lens, and this lens. And we can define here power of the combination, because we have the two lenses. That means if ray start traveling from this object toward the right direction, it will interact with the lens, then this lens that interact with the mirror. It will return back, again interact with this, again interact with this, and finally reach to the same medium. That means interaction of the ray with this lens is twice with this lens and single time with this mirror. That means power of the combination should be 2PL1 plus 2PL2 plus PM, right? It means we need to calculate the power of this, and power of this. First of all, we need to calculate the focal length of this lens. For this, we need to use the lens maker formula. Lens maker formula we know 1 upon f equal to mu minus 1 upon r1 minus 1 upon r2, right? R1 here, because we know the center of curvature of this surface will be on the left hand side, so it should be with the negative sign. Center of curvature of this surface again will be in the leftward direction, again with the negative sign, and we know the value r1 equal to 80 and r2 equal to 40. That's why we have substituted minus 80 and minus 40. So after calculation we will get the value 0.6, 1 upon 40 minus 1 upon 80, and after calculation this is equal to finally 3 divided by 400. That means focal length of this equal to 400 divided by 3 centimeter. We can convert this value into meter, because for calculating power we need to calculate this focal length in meter. So this is 4 by 3 meter, right? Now power of this lens equal to 1 upon focal length. That means 1 divided by 4 by 3. So this is the power of the first lens. This is equal to 3 by 4 diopter with the positive sign. Similarly, we can calculate the focal length of the second lens. Here also we can observe the radius of curvature, but for the both surface will be negative, because center of curvature for both surface will be on the left direction. And here we know this surface has got the radius of curvature 40, this surface has got the radius of curvature as 20, right? So we can now substitute the value, corresponding value, and mu here it is given as for the second lens 1.2. So let us substitute the value in the lens maker formula. If we calculate this value, this is equal to 0.2 multiplied by 1 by 40, right? And from this expression we can find the focal length of the second lens 200 centimeter, that is equal to 2 meter. Okay. Now we can find the power of this second lens, this lens. Power equal to 1 upon focal length with a positive sign. So this is equal to 1 by 2, that is equal to 0.5 diopter. Now let us calculate the focal length of this mirror. We know the focal length equal to half the radius of curvature, and we know radius of curvature of this is 20 centimeter, and center of curvature will be on the left hand side. That means this radius of curvature should be substituted with the negative sign. That means focal length should be equal to minus 20 divided by 2. So here we can write the focal length equal to minus 20 divided by 2. This is equal to minus 10 centimeter. We can convert this value into meter by dividing by 100. So it is equal to minus 1 by 10 meter. Now power of the mirror, we know this is equal to minus 1 upon focal length of the mirror. So it is equal to minus 1 divided by minus 1 by 10. So this is the power of the mirror. This is equal to plus 10 diopter. Now we can calculate the power by using this relation. So let us write the power of the equivalent mirror, that is equal to 2 PL1 2 PL2 plus PM. Now we can substitute this value. This was 3 by 4 diopter, and this value is 0.5 diopter. This is 10 diopter. So let us substitute this value. On calculation, this value is 12.5 diopter. Now we know this system is acting as a mirror, and we know the formula for the focal length of the mirror equal to minus 1 divided by power. So we can calculate the focal length of this system by this formula. Now we can substitute this value. This was 12.5 diopter. So this is minus 1 divided by 12.5 meter. This is the focal length of this system, combined system. We can convert this value into centimeter, multiply by 100. So we can write here 1000 divided by 125, that is equal to 8 centimeter with a negative sign, right? It means this system is acting as a concave mirror of focal length 8 centimeter. Now we are given the object distance as 12 centimeter. This is 12 centimeter, the object distance. Object is placed on the left side. That means rays are traveling from left to right. For measuring the object distance, we need to move from right to left. That means U should be, object distance sign should be negative, right? And we will use the mirror formula here. So we can write 1 upon V plus 1 upon U equal to 1 upon F. And U equal to, as discussed, it is equal to minus 12, and this is minus 8. So let us substitute these values. Now we can find the value of V. This is equal to 1 divided by 24, right, with the negative sign. So this is minus 24 centimeter. Minus 24 centimeter means in front of the mirror. That means we can say the final image will form at a distance 24 centimeter in front of the system.